Hello and welcome back to another session of serde-yaml. It's Byron speaking. And in the previous session we have realized that there is the need for actually reading the entire document. And I decided to do this on camera, and right now I realized that, okay, while reading this, I want to take my notes in form of either just notes for the README or notes for documentation or actual code. So what we're doing now is to transfer these examples into our test suite. This means we will have the data for serialization and for serialization testing and the deserialization testing. Right now we're obviously working on the serialization part only, and it's grunt work in a way, but it has to be done. So let's go ahead with example 2.4. First, the Python version. That's going to be a list of 2 dicts with that particular data here. And yeah, I think I copy this. Let's see. I copy this first, and then I take this as a comment. Obviously, this will need some work to actually be somewhat useful. Okay, so that's going to be D equals a list of dicts, and the dicts we can just put like that. Here we have a comma. Oh no. Here we have a comma. That was a hotkey hiccup, by the way. Yeah, how should that look like, I guess? 1 indentation level should suffice here. Kind of like that. Is it pretty? No, it's not. I don't know why it destroyed my indentation here to the point it did. Like that. Yeah, that took longer than expected to get right, and we are not even done yet. Like this, comma, 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 here we go, like that, and this finally, and now the commas, and that is that. Cool, so that should do something useful now. Yeah, should also, seems to lint okay. And now the actual example 2.4. Pretty printing. Let's see what we get if we do that. Oh, true. My secondary screen is not actually connected here. And now it is. I hope my recording will not be destroyed now, but I think this still works anyway. Cool. Nice. Did that work? Sidebar I don't need. Oh look. Something it doesn't like here. So what's the problem again? Is it a syntax error, non-ASCII character? Line 3073. What? Ah, here, I guess this is the one that it kind of doesn't like. In the comment, awesome. Okay, so now we have the data here. Does it look like it's supposed to look like? It actually does. Nice. Kinda. There's a new line missing here. But this is something, you know, if it's not output by Python, I also wouldn't require it to be output. And right now I don't have the terminology required to know how I should write this, you know, how do I say, okay, there's supposed to be a new line here. I have no idea. That looks better, obviously. But it's good to know that this works as well. Yeah, so let's do it like that then. And now, yeah, this is a vector of specific structures. I guess I just have a player structure and then a new type that is a vector of these players. Let's try that. I'm not sure if this is what you want, but I'll just try it. Okay, so I guess we start off as this one. Player. So we have a name, which is a string. Average and HR. Name, HR, average. Average is a float, and that's a U32. So that's my player. And my example to 4 shall be a new type of a vector of players. So that I can now have a default in the respective serialization and deserialization implementation. So let's try that first. Let's make tests. Let's see if that builds into something useful. Wow, 700 lines of code. So that seems to be working. Good. And now all we have to do is add the default here with the respective values. I guess I wanna, yeah, where do I copy this from? Let's copy it from here, why not? Impl default for example to 4. And then we have fn default that returns a self. And then example to 4. How's that specified? I think like this, right? Like a constructor with a vec of a player. Did I copy this? I did. Let's just keep it there for now. Vector of player 1. Let's use this one first. So name is Mark McGuire. Again, we had this guy before. To owned. May call it toString. I kind of like this more. HR is 65 and average is 0.278. Okay. Now I should be able to put down. Yeah, actually let's do it like this, huh? Like that. So I should be able to put down another player relatively nicely. Like that. So that is 63, 2.88, Sammy Sosa. Do these actually exist? Maybe. I could Google it, but on the other hand, I don't care enough to do that. Example, well, on the other hand, was the author of the spec a fan of football? Apparently so. This guy does exist. Sammy Sosa also? I guess so. Yep. Baseball. I see. So there is a fan, obviously. So that's the default. Nice. Now I should be able to just stupidly copy paste my test case as I did before. If I would be more fluent with macros, I would probably use them now. But on the other hand, I kind of feel comfortable enough to do that copy pasting here. Yeah, that's example 2.4. Well, and we have to make work every single one of them. Not to forget. So that should compile, that's all I need. And it does. Good. 2.4. It takes a little while to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 16, 18, 20, 22, 24 to go. Wow. We just have 4, man. Each takes time. Because we have to do it in Python, and then we have to do it in the data structure definition. But hey, that's how it is. You know, what can I say? So that's just a different presentation style here. Example of sequences. So here we say default sequence false or something. Default, yeah, ops pretty is not used here. I think that should automatically give me this condensed version. Oh, excuse me. I'm still not totally back here, but I'm nearly there in terms of having survived my sickness here. All right, so let's set up the data structure. Here we go with a sequence of sequences. Yeah, the cool thing is in Python, we should be able to take this in rather easily. Let's do that. Put it here. Then we have a few strings. Defining this in Rust will be a bit more difficult because it's different tuples with different types. And I guess we need a structure, yeah, some sort of tuple of tuples we might need for this. And let's see if nested tuples work natively. I think they should. They should. So this time no ops pretty. That's a point here, I guess. We might also not be able to, we might be able to, or I might not be able to specify this that way. This could be happening. Because this is kind of a long form, whereas this one is suddenly a short form. Who knows, you know, how can that be? We'll see what it outputs though. Let's see. Oops. Like that. Oh look, that actually works. I don't know why. I have no idea why it decides to do it that way. I'm looking forward to get that to work, right? But hey, it's good to see. Awesome. And it's exactly the same, right? Yeah, it is. All right. Okay, so how do we represent that? Yeah, I would go for a tuple of tuples. I mean, that's kind of the same type here. But yeah, let's go for a tuple of tuples. Could be a new type. And even there, I wonder... Oh no, wait, I could just go with a tuple of tuples, then I don't need a new type. Yeah. And this tuple should automatically translate into lists of some sort, so I guess we would be good here. So let's try that. Let's try it with example 5. And the data is supposed to be this here in a slightly different fashion. Tuple of tuples should just be fine. Here we go with a tuple. Of tuples. And then all these strings want to be real strings. Yeah, I should be able to just do find and replace. Ideally only in that selection. Is this in selection here? In selection, yeah. Like this. So that should be serializable. Because, yeah, each of these are serializable and the recursion should be handled correctly by the compiler natively. And we want to compare it to 2.5, 2.5 to 5. Yeah, that's kind of what I think could work. Look at that. So let's have a look at 2.5 then. So we get we get a list of lists here. And it wants to have dashes, obviously. Yeah, cool. But that is done. Took us 6 minutes. It takes a while. So that will be a few hours of additional work and kind of boredom because it's so repetitive. All right, so let's do this. Mappings of mappings. Let's just do it. Mappings of mappings. So here I would go again with an ordered dict kind of style. D is an ordered dict. Let's close it down here. And this one is, that's the key. And that's another, yeah, we need an ordered dict here as well. That's HR, oops. Let's go with single quotes here. HR 65, average that. So that's, wait a second, here something missing. Yeah, that closes this tuple. And actually the other one, look at that, that's kind of a short and a, yeah, that's kind of two different representations. We can't have that. So this will not look the way, I mean, we can't specify this. We can't have it the one way for this guy and for the other guy the other way. That doesn't work. Even though we might be able to specify that we want new lines there. And I'm not sure how that works. This could be part of our dump definition here. Ah, that's cool. It's something we might want to take a note into a test suite as well. Flow collections. Anyway. So where is that again? API stability is not guaranteed. Nice. Line break. Yeah, so here, explicit start, explicit end. I think this is the document. Explicit document start, explicit document end, if you don't mind. Yeah, I don't know. So I guess this can't be can't be specified really, not here. But that doesn't matter, because we might want to add this once we get into the game. So yeah, let's just copy this, because it's going to be the same. Oops, 63 2.88. Same data, different presentation. Yeah, it's 2.6. How would I want to do this? Pretty? Probably not pretty. Let's not do it pretty. Let's do it like that. Let's see what comes out of that. I have no idea. Oops. Doesn't like this. So that's supposed to be a tuple of tuples here. Okay, here we need a tuple of tuples. Wow, that's kind of overkill, but I guess that's what we need. So let's see. Yeah, so it kind of comes out as similar to the first line here. Yeah. But that's good. That's good enough. So how do we do it? We have a player. That's a player structure again, huh? It's the same thing. Player name HR. Okay, the name now is different. So it's not the same structure. It's a hash map of stats or something. Let's have a stat structure. Player stat. So now no name, but instead we have a new type with a hash map to what? To 6. True, the last one was just a tuple for us. To 6, that's a hash map. No, we need also, oh, we have a collection already. That's good. So that's a hash map from string to player stat. And now the default implementation shall be impl default, for example, to 6. Fn default shall return a self, which is example to 6 with, sorry, we want to actually call the constructor here and pass in a hash map that is that has the respective items. So how does that work? I think we just use insert. Let mat h be a hash map new. And let's put in h here. And type inference will do all the nasty work for us. We do, it's the same names here, right? So it's Mark McGuire to string. And the item is player stat. I will try to compile it just to see that it actually works. So HR is 65 and average is 0.278. So that should already do something useful. And then we are just missing the second player. So let's add the test right away. Gee, that's gruntwork. To 6 to 6. Yeah, seems to work. So let's add the other guy. Sammy Sosa. 63 and 288, right? Yeah, that's the guy. So here we go. That will work nicely. So now structures. YAML uses 3 dashes to separate directives from document content. I have no idea how that would work. This also serves as a signal to start the document if no directives are present. 3 dots indicate the end of the document without starting a new one for use in communication channels. Okay, two documents in a stream, each with a leading comment. So how could we serialize that? I don't know. Yeah, I don't see a way that this can work. Unless we say, well, each item in a vector is supposed to be starting a new document, but I don't know. Is there some way to handle documents here? Parses the given stream and returns a Python object constructed from the first document in the stream. If there are no documents in the stream, it returns none. Load all parses the given stream and returns a sequence of Python objects corresponding to the documents in the stream. Save load. Okay, so what about serialization? How do you deal with dump all? Serializes the given sequence. Okay. So this is something we can support actually. So let's use it. We can do this. It's going to be difficult to have arbitrary data structures in dump all. Well, so I'm just saying the Rust interface is going to be interesting, but Python can do it, and I think we should think about how to do this in Rust as well. After all we need is a serializable interface, maybe fat pointers or dynamic dispatch to do that. I think getting an iterator with dynamically dispatchable serialized interfaces could do the job for us. Yeah, so let's do this in Python first. Dump all, so that's a sequence of stuff. Yeah, so the comment obviously I can't have. Leading comment information I will just discard here. And then we have D being a, let's make it a tuple of stuff. A tuple of a list of these things. I could have stayed in the multi-line mode like this. Yeah. Like that, like that. I'm just wondering how this should look like. Kind of looks ugly, but on the other hand, who cares really? So let's do the same processing here. So that's already it. Kind of, except for the enclosing brackets for the list. There we go. Yeah, I think one more to the right I can do that. Okay, so that's 2 documents. Now I go with dump all. And that's 2.7. 7, dump all. And there you have your sequence of stuff. So let's see what comes out of there. Did it make test? Yeah, it did. Huh? Yeah. So there's no end of document. Okay, it doesn't need an end of document. So let's try to manipulate this to get exactly that. This should be possible. So this document start, right? Document explicit start should be given here. explicit start is true, I guess. And now I would expect, no. What happened? Cargo dock open. Why is that coming in there? Ah, damn it, come on. And now I would expect this to be here, yes. And I think everything else is just beautification. So I want to have the pretty one as well. So opts is pretty, ops pretty. Is there a copy? I think there's a copy method here on these guys. I hope so. And then I can say ops explicit start shall be true. Like this, and then I can just pass my custom ops here. So that should be a bit better. Yep. That's pretty much how it looks like. And this is, they can do it Python. In Python, I definitely have to be able to do it in Rust. That's the point here. And explicit end, this is kind of the same thing and a variation of it. Even though I have no idea if this time is a specific timecode thing or not. I guess here we have a listing, the schema mapping. I've seen this somewhere here. And here we might know okay, it can do date time. Timestamp. So it has the notion of date time. I don't know how date times are looking like, and there seems to be no example. Python, YAML, date time, let's see. Let's see how that would look like. Okay. So that's how the timestamp looks like then? Interesting. What? Okay. That looks interesting. Okay, so that's how such a timestamp looks like. So yes, this is indeed a time object. Interesting. So datetime. I'm not sure how I can get rid of the date portion. Let's try to use some sort of time here, huh? Let's try that. Maybe I can get some formatting going, like the one I see. Where have I seen this? Here, right? Timestamp. But apparently it needs explicit type annotation here, because the parsing otherwise doesn't work. Yeah. Python provides the shortcut for serializing a certain timestamp. Yeah. Yeah, I think for now I would just take it as a string. Also, I don't think if there is a particular datetime object available even in Rust, or if this is something external to some libraries. I know there's duration and something like that. Possibly a time object, but I don't know enough about it just now. So I don't know how it's supposed to handle this. Okay, So let's get ahead. Let's just see this as a string for now. Yeah. Play by feed for game. Oops, here we go. Let's take the data and convert it into a sequence. It can be a tuple, can be a list, who cares, of ordered dicts. Like this. And then I think I'm going, yeah, we just have a tuple syntax here. So multi-line editing should be just fine for us. Like that. Then we have a comma here. This, that, and that. Cool. So that's the first, that's the first ordered dict. And then we have a comma, and then we have another ordered dict with time and player. Huh. I also didn't even use this example yet in Rust. I should try that at some point, because that needs a completely different functionality here. Yeah, I might mark it with a to-do or something. But yeah, let's finish this one for now. So we go with that. Then we have a string. This is a comma. Where's the player name? Oh, look at that. I only took half of it. So let's try that again. So like this, like that, and there we go. Now we close the thing down. Nope. And we are done. Let's put it one to the right. Okay, so that's my dump all list right now. Dump all. Yeah, the options, they will need to be modified. Opts, I think explicit end should be true as well here. And that should be that, right? I would expect to get something like we see here now. Oh, look at that. Oh no, wait, that's the next one with with anchors. That is something we might never support. Oh, look. Yeah, it's a string. Oh. I'm not sure why I didn't put this into a string as well. So yeah, that's probably easy to get right. So it's a string to string here. That's good. Actually a struct with just strings, I guess. That's what we could put here. And then we have two structs and a vector, and we wanna kind of put this somehow. And right now we don't have an interface for that. So 2, 7 to 8 we still need to put 2, 7 to 8 we still need to put into the Rust portion of the code, not to forget. Here we have the data. That even looks the way it's supposed to look like. That's nice. And yeah, let's get to 7. How would we define that data? I think the data definition is something we can already do. So here we have just string vectors, 2 of them, and they're serializable. Yeah, so I guess it's a new type again. And I also guess I can just copy this from here, can I? Yeah, and these are only serializable, right? Not to forget. Anyway, so that's example 2.7. It's a new type that has a vector of static strings. Maybe even a slice of these guys. What do I want? I tried the vec already. Let's have a slice this time. So it's a slice of these. And now in the default implementation, impl default for example 2.7. We have fn default, which I mean is a good practice, right? Having done it like 10,000 times now. So example 2.7 takes a slice. Oh no, wait. It's a bunch of these, right? It's an iterable. So this must be boiling down to a slice of slices of these. That must be that. So that is a slice of slices. And now in here we can place all the wonderful names like this. Yeah, let's put it onto one line here like that. And then the next one like this. Voila. All right. So that should be the data structure. Again, I have no idea if that is implemented. It could just tell me that it is not, but I will find out. So serialize should possibly work. And the data structure itself is also looks sound to me. But who knows? Let's try it. Should fail right away if it fails. Missing lifetime specifier. What? So yeah, it's all static, man. Which is truly the case, right? Borrowed value does not live long enough. I thought so. Okay, so let's use vectors then. Yeah, because these actually live on the stack only. And what I could do is use arrays, but for arrays of a certain length, I'm pretty sure that nothing is implemented there, so that is something we can forget. So I guess we need a vector of vectors of strings. Vectors of these guys. And this should just return serializable things. So this is kind of the vector for the documents here. All right, so now I say vec. And here I say vec. What did I just do? I think I changed the cursor or something. Yeah, and that is that, right? This should be fine now. So with a little bit of luck, this can actually compile. It does. And now we can add the test here. 2.7 default. Then to do multi-document handling. And the multi-document handling is in theory just something we can, that can be the underlying thing. So if we have a single document that we want to serialize, we can just call the multi-document thingy implementation with configuration that will make all the document indicators go away. And that's how I would actually want to implement this. You know, it doesn't really matter. It's just a little bit of refactoring when we finally provide this. Yeah, assert false. Yeah, can I just panic here? Needs implementation. I don't know if my entire test suite then breaks down or if, yeah, let's see. We'll find out. So that should now error. True. And let's just kick this. Two, 7 fails. That's good. 2, 6, 2, 7, 2, 7 std out. Panicked multi-document handling needs implementation. All right, cool. Now the next one. 2, 8. Yeah, that's a. Yeah, I would go for a hash map this time. Hash map, string, string, 2 of them. And I go for, yeah, let's go for static once again. Hash map, oops, static string to static, oops, that's wrong, to static string. Like that, right? Does that work? Should work. So far, so good. I should compile. And now we just implement the default here. Let's be lazier and copy this. And then we go with example 2.7. Oh yeah, it just takes the hash map here. That might be a hash map new, same thing as we did previously. And now we can insert our values. Oh yeah. Yeah. Actually, that's wrong here. We need a vector of structures just because, unfortunately, that we would lose order otherwise. And in Python, we keep order using order_dix, but we don't have that in Rust. So we need a structure. Yeah, well. Pub struct. What is this? It's a game event or something. Time shall be a static string. Everything is a static string. Player. Action. Like that. Now we have a hash map. Actually, we have a vector of game events, and can just set it up like this. Game event. Oh yeah, these guys have to be. Actually, they don't have to be pub, but I just make them pub anyway. Because within this module, we can access private fields. Fortunately, we can't do it outside. Considering we have a default implementation, you know, it's kind of alright. But anyway, let's just do this. Time shall be. Oh yeah, no, I need this data here. Let's just put it here for now. Time should be this, and player should be this, and action. I could probably get away by putting this here, huh? Game event, like this, So all I would have left to do is to do some fancy multi-line editing. What do you think about that? Yep. Totally. Nice. Grand Slam. Yeah. So that is the data structure that I'd see here. Yeah, let's kick this out. And bring in the respective test here with additional multi-document handling that needs additional implementation. And it's more about the options that we test here. Really? What is this? That's a weird error. So some issue is in here. And I don't see it right now because it doesn't give me any information. So out RS. Oh yeah, it probably doesn't give me any information because I hide the output. What do you say now? I think now you have to say more, huh? Unclose delimiter stuff, 2.8. Oh look, that's actually 2.8 here. So that was one part of the issue. And then, let's see, that's closed. That's closed. That's also closed. Looks good to me. In 133. Really? So something is very unclosed here. That is closed. That is closed. Yeah. Oh, this is not closed here. Yikes. Oh, that's better. Maybe I want to use the left side a bit more and put this here. Oh, and now it's a duplicate function. That is my copy paster, but now we have 2.8 as well. Oh man, that's a lot more work. So we're already nearly an hour in, so I'll just take a, call this a session and wish you a great evening. I will be back because I want to finish this tonight. So thanks for watching and have a great day.